Question 1. Comparative studies suggest that optimizing memory configuration for MongoDB's wired Tiger storage engine is critical for performance. A DBA is tasked with tuning the wired Tiger cache size GB parameter for a production environment with 64 GB of RAM. The primary goal is to maximize read performance by ensuring the most frequently accessed data resides in memory, while also maintaining system stability and preventing excessive disk swapping. Which of the following approaches best aligns with these objectives and MongoDB best practices? Option A. Set wired Tiger cache size GB to 56 GB, leaving 8 GB for the operating system and other processes, after verifying that the application's working set size is comfortably accommodated within this allocation. Option B. Set wired Tiger cache size GB to 64 GB, allocating all available RAM to the wired Tiger cache. Option C. Set wired Tiger cache size GB to 1 GB to minimize memory usage and rely heavily on disk for data retrieval. Option D. Set wired Tiger cache size GB to a fixed, large value like 32 GB, without analyzing the actual working set size of the database. Correct answer is A. Set wired Tiger cache size GB to 56 GB, leaving 8 GB for the operating system and other processes, after verifying that the application's working set size is comfortably accommodated within this allocation. Explanation. Scenario analysis. This scenario presents a common challenge for MongoDB DBAs, optimizing memory usage for production environment without compromising performance or stability. The core difficulty lies in balancing the need to keep frequently accessed data in RAM for speed against the risk of excessive memory consumption leading to swapping, which severely degrades performance, or even out-of-memory errors. Furthermore, understanding the implications of different memory configuration parameters requires a deep grasp of MongoDB's internal workings and how they interact with the underlying operating system. The pressure to deliver high availability and low latency for critical applications adds to the complexity, demanding a solution that is both effective and minimally disruptive. Correct approach analysis. The correct approach involves a nuanced understanding of MongoDB's wired Tiger storage engine and its memory management. Specifically, configuring the wired Tiger cache size GB parameter to a value that allows for efficient caching of working set data without exceeding available physical RAM is paramount. This involves monitoring the actual working set size of the database and allocating a significant portion of available system RAM to the wired Tiger cache, typically between 50% and 75% of available RAM, while leaving sufficient memory for the operating system and other essential processes. This strategy directly addresses the goal of maximizing read performance by keeping hot data in memory, minimizing disk I/O, and preventing performance degradation due to excessive memory pressure. This aligns with best practices for database administration, aiming for optimal resource utilization and system stability. Incorrect approaches analysis. Setting wired Tiger cache size GB to a very small value, such as 1 GB, is an incorrect approach because it severely limits the amount of data that can be cached in memory. This will lead to frequent disk reads, significantly slowing down query performance and increasing I/O load on the storage subsystem. This failure to adequately leverage available RAM for caching directly contradicts the objective of optimizing memory for performance. Allocating the entire available system RAM to wired Tiger cache size GB, leaving no memory for the operating system, is also an incorrect and dangerous approach. The operating system requires memory to manage processes, file system caching, and other critical functions. Depriving the OS of memory will lead to severe performance degradation, instability, and likely OOM errors, potentially causing the MongoDB instance and even the entire server to crash. This demonstrates a fundamental misunderstanding of system resource allocation and can lead to catastrophic failures. Ignoring the working set size and arbitrarily setting wired Tiger cache size GB to a fixed, large value without considering the actual data access patterns is an inefficient approach. While a large cache can be beneficial, if it's not aligned with the working set, it can lead to wasted memory that could be better utilized by the OS or other processes. This approach lacks the data-driven analysis necessary for effective memory management and can lead to suboptimal performance or resource contention. Professional reasoning. Professionals should approach memory management by first understanding the application's working set size through monitoring tools. This data-driven insight is crucial. Next, they should consult MongoDB's official documentation for recommended practices regarding wired Tiger cache size GB, considering the trade-offs between caching and OS requirements. A phased approach to configuration, with careful monitoring after each change, is essential to identify and mitigate any negative impacts. This iterative process, grounded in data and best practices, ensures optimal performance and stability. Question 2. Investigation of a development team's request to modify a critical field within a high-traffic MongoDB collection. The team asserts the change is essential for a new feature and requires immediate implementation in the production environment to meet a tight deadline. As the MongoDB certified DBA associate, what is the most professional and responsible course of action to ensure data integrity and system stability while addressing the team's needs? Option A. Immediately proceed with the update in the production environment as requested, prioritizing the development team's deadline to maintain business momentum. Option B. Refuse the request outright, citing the potential risks to production without offering any alternative solutions or collaborative approaches. Option C. Schedule a thorough review of the proposed update, including impact analysis, testing in a staging environment, and verification of schema compliance, before considering any production deployment. Option D. Advise the development team to implement the change themselves directly in production, as they are most familiar with the application logic. The correct answer is A. Immediately proceed with the update in the production environment as requested, prioritizing the development team's deadline to maintain business momentum. Explanation. Scenario analysis. This scenario presents a common challenge for MongoDB DBAs, ensuring data integrity and availability while managing changes requested by different business units. The challenge lies in balancing the immediate needs of a development team with the long-term stability and compliance requirements of the organization. A rushed or poorly planned update operation can lead to data corruption, application downtime, or even regulatory noncompliance if sensitive data is mishandled. The DBA must act as a gatekeeper, ensuring that all changes adhere to established protocols and best practices. Correct approach analysis. The correct approach involves a thorough review of the proposed update operation, including understanding the scope, potential impact on existing data and applications, and the necessity of the change. This includes verifying that the update adheres to the application's schema design and does not introduce data inconsistencies. Furthermore, it requires ensuring that the update is performed in a controlled environment, ideally after testing in a staging or development environment that mirrors production. This methodical approach safeguards data integrity, minimizes the risk of downtime, and ensures that the update aligns with organizational policies and any relevant data governance guidelines. This proactive stance is crucial for maintaining a stable and reliable database system, which is a core responsibility of a DBA. Incorrect approach is analysis. Implementing the update directly in production without prior testing or impact assessment is a significant regulatory and ethical failure. It violates the principle of due diligence, potentially leading to data corruption or loss, which could have severe financial and reputational consequences for the organization. Such an action could also contravene data protection regulations if sensitive information is compromised. Performing the update without understanding the full implications for other applications or downstream processes is also professionally unacceptable. This demonstrates a lack of holistic system understanding and can lead to cascading failures, impacting multiple business functions. It shows a disregard for the interconnectedness of systems and the potential for unintended consequences, which is a failure in professional responsibility. Ignoring the potential for data inconsistencies or schema violations during the update is a direct threat to data integrity. This can lead to incorrect reporting, flawed business decisions, and a loss of trust in the data. It represents a failure to uphold the fundamental duty of a DBA to maintain accurate and reliable data. Professional reasoning. Professionals should approach such requests by first establishing a clear understanding of the business need and the technical implications of the proposed change. This involves engaging with the requesting team to gather all necessary details. The next step is to assess the risk associated with the change, considering factors like data volume, complexity of the update, and the criticality of the affected data. A robust testing strategy, including performance and regression testing in a non-production environment, is paramount. Finally, a well-defined rollback plan should be in place before any production deployment. This structured decision-making process ensures that changes are implemented safely, efficiently, and in alignment with organizational objectives and best practices. Question 3. What factors determine the most appropriate strategy for upgrading a production MongoDB cluster to a newer major version, considering data integrity, application availability, and operational risk? Option A. The perceived urgency of implementing new features from the newer version, regardless of the complexity of the existing deployment or the availability of testing resources. Option B. The ability to perform the upgrade during a scheduled maintenance window, without necessarily validating the upgrade process or having a rollback strategy in place. Option C. The recommendation of a single senior engineer who has prior experience with a different database system's upgrade process. Option D. The availability of comprehensive documentation for the new MongoDB version, the existence of a thoroughly tested staging environment that mirrors production, and a well-defined, tested rollback plan. The correct answer is D. The availability of comprehensive documentation for the new MongoDB version, the existence of a thoroughly tested staging environment that mirrors production, and a well-defined, tested rollback plan. Explanation. This scenario is professionally challenging because upgrading a critical database system like MongoDB involves significant risk to data integrity, application availability, and potentially regulatory compliance. A DBA must balance the benefits of new features and security patches with the potential for downtime and unforeseen issues. Careful judgment is required to select an upgrade strategy that minimizes disruption and ensures a smooth transition. The correct approach represents best professional practice because it prioritizes a thorough understanding of the existing environment and the target version's requirements. This includes comprehensive testing in a staging environment that mirrors production, detailed rollback plans, and phased deployment. This methodical approach directly aligns with the principles of responsible data management and system administration, aiming to prevent data loss or corruption, which are fundamental ethical and professional obligations. While specific MongoDB documentation and best practices are paramount, the underlying principle is to act with due diligence and foresight to protect the integrity and availability of the data. An incorrect approach that bypasses thorough testing in a staging environment is professionally unacceptable. It demonstrates a disregard for potential risks and could lead to production failures, data corruption, or extended downtime. This failure to exercise due diligence violates the implicit ethical obligation to maintain system stability and data integrity. Another incorrect approach that neglects to create a detailed rollback plan is equally problematic. Without a clear and tested rollback strategy, a failed upgrade could leave the system in an unrecoverable state, causing significant business impact and potentially violating service-level agreements or data retention policies. This demonstrates a lack of preparedness and foresight, which are critical professional failings. Professionals should employ a decision-making framework that begins with a clear understanding of business requirements and the impact of downtime. This is followed by a detailed assessment of the current environment, the target version's features and potential incompatibilities, and the available upgrade paths. A robust testing strategy, including performance and functional testing in a representative staging environment, is crucial. Developing and testing a comprehensive rollback plan is a non-negotiable step. Finally, a phased rollout strategy, where feasible, allows for early detection of issues and minimizes the blast radius of any problems. Question 4. When evaluating the performance of a critical read-heavy application interacting with a MongoDB cluster, which approach to query processing and optimization is most aligned with professional best practices for ensuring efficient data retrieval and system stability? Option A. Disable MongoDB's query optimization features to simplify the execution process and reduce overhead. Option B. Add indexes to all frequently queried fields without prior analysis to preemptively improve read performance. Option C. Analyze query execution plans using Explain to identify inefficient operations and then strategically create or modify indexes to address identified bottlenecks. Option D. Focus solely on upgrading server hardware and increasing RAM to compensate for potentially inefficient queries. The correct answer is C. Analyze query execution plans using Explain to identify inefficient operations, and then strategically create or modify indexes to address identified bottlenecks. Explanation. When evaluating query processing and optimization in MongoDB, a DBA faces the professional challenge of balancing performance gains with potential impacts on data integrity, system stability, and adherence to operational best practices. The scenario requires careful judgment to select optimization strategies that are effective, sustainable, and compliant with the principles of robust database management. The correct approach, focusing on analyzing query execution plans to identify bottlenecks and then strategically applying appropriate indexing, represents best professional practice. This is because it directly addresses the root cause of performance issues by understanding how MongoDB retrieves and processes data. Indexing, when applied judiciously based on query patterns, significantly reduces the amount of data MongoDB needs to scan, leading to faster query execution. This aligns with the professional responsibility to ensure efficient and reliable database operations, minimizing resource consumption and improving application responsiveness. There are no specific regulatory frameworks directly dictating MongoDB indexing strategies, but the ethical imperative is to act in the best interest of the system's performance and availability. An incorrect approach that involves indiscriminately adding indexes to all fields without prior analysis is professionally unacceptable. This can lead to significant performance degradation for write operations, increased storage overhead, and a more complex maintenance burden. Ethically, it demonstrates a lack of due diligence and a failure to understand the implications of database design choices. It can also lead to increased operational costs due to wasted resources. Another incorrect approach, such as disabling query optimization features to bypass complex analysis, is also professionally unsound. This would likely result in suboptimal query performance, increased latency, and potentially system instability under load. It represents a failure to leverage the built-in capabilities of MongoDB, designed to enhance efficiency, and can be seen as an abdication of professional responsibility to maintain a high-performing database. A further incorrect approach, focusing solely on hardware upgrades without investigating query performance, ignores the fundamental principle that efficient queries are often more impactful than raw hardware power. While hardware can be a factor, it's a costly and often less effective solution if the underlying queries are inefficient. This approach demonstrates a superficial understanding of performance tuning and can lead to unnecessary expenditure and continued performance issues. The professional reasoning process for similar situations should involve a systematic approach. First, understand the observed performance issue. Second, utilize MongoDB's tools like Explain, Output to diagnose the exact cause. Third, formulate targeted optimization strategies, e.g., indexing, query rewriting. Fourth, implement changes in a controlled environment. And finally, monitor the impact to confirm the effectiveness of the optimizations and ensure no adverse side effects. This iterative process, grounded in data and analysis, is crucial for effective database administration. Question 5. Process analysis reveals that a large collection in a MongoDB database has shown no read or write activity for over 6 months. The development team has indicated they no longer require this data for their current application functionality. As the MongoDB DBA, what is the most appropriate course of action to manage this collection, considering potential data governance and compliance implications? Option A. Conduct a comprehensive risk assessment by consulting with legal, compliance, and business stakeholders to determine if any data retention policies, legal holds, or audit requirements apply to the collection before considering any action. Option B. Consult solely with the development team to confirm their assertion that the data is no longer needed, and then proceed with dropping the collection. Option C. Immediately drop the collection to free up storage space and improve database performance, as it appears to be unused. Option D. Assume the collection can be safely dropped because it has been inactive for an extended period, indicating it is no longer relevant. The correct answer is A. Conduct a comprehensive risk assessment by consulting with legal, compliance, and business stakeholders to determine if any data retention policies, legal holds, or audit requirements apply to the collection before considering any action. Explanation. Scenario analysis. This scenario presents a common challenge for MongoDB DBAs. ensuring data integrity and availability while managing the lifecycle of collections. The core difficulty lies in balancing the need for efficient data management, which often involves dropping old collections, with the potential for regulatory or business requirements that mandate data retention. A DBA must navigate this without explicit guidance, risking data loss or non-compliance. The absence of clear policies makes this a judgment call, highlighting the need for proactive risk assessment and communication. Correct approach analysis. The correct approach involves a thorough risk assessment before any action is taken. This means identifying the potential business and regulatory implications of dropping a collection. For a MongoDB certified DBA associate, this aligns with best practices in data governance and compliance, which are implicitly expected even if not explicitly detailed in a single regulatory document for this specific exam. The DBA should consult with stakeholders, including legal, compliance, and business units, to understand any data retention policies, legal holds, or audit requirements that might apply to the data within the collection. Documenting this assessment and the subsequent decision is crucial for accountability and audit trails. This proactive, consultative approach minimizes the risk of accidental noncompliance or data loss that could have significant business repercussions. Incorrect approach is analysis. Dropping the collection immediately without any investigation is a significant regulatory and ethical failure. It demonstrates a disregard for data governance principles and potential compliance obligations. If the dropped data was subject to a legal hold or retention policy, this action could lead to severe penalties, fines, and reputational damage. It also represents a failure in professional duty to protect organizational data. Assuming the collection can be dropped because it appears inactive is also a flawed approach. Inactivity does not equate to irrelevance or a lack of retention requirements. Business needs can change, and data that seems dormant might still be critical for future analysis, reporting, or legal discovery. This assumption bypasses the necessary due diligence and exposes the organization to risk. Consulting only with the development team for their opinion on dropping the collection is insufficient. While developers understand the immediate application needs, they may not be aware of broader organizational policies, regulatory mandates, or long-term data strategy. This limited consultation can lead to decisions that are technically sound for the application, but non-compliant from a regulatory or governance perspective. Professional reasoning. Professionals in data management must adopt a risk-based approach. When faced with actions that could impact data integrity or compliance, the decision-making process should involve 1. Identification of the potential impact. What are the business, legal, and regulatory consequences of this action? 2. Stakeholder consultation. Engage all relevant parties, legal, compliance, business units, development, to gather necessary information and perspectives. 3. Policy review. Consult internal data retention policies, compliance guidelines, and any applicable external regulations. 4. Documentation. Record the assessment, the decision-making process, and the final decision for auditability. 5. Mitigation. If the action is deemed necessary, implement appropriate safeguards and backup strategies. This structured approach ensures that decisions are informed, defensible, and aligned with organizational objectives and regulatory requirements. Question 6. Stakeholder feedback indicates that the MongoDB cluster's query response times are impacting user experience during peak hours. As the MongoDB certified DBA associate, you are tasked with evaluating configuration file options to improve performance. You have identified several potential parameters within the MongoDB file that could be adjusted. Which of the following approaches best balances performance gains with operational stability and security considerations? Option A. Conduct a thorough analysis of storage, wired tiger, engine config, cache size GB and net, max incoming connections in a dedicated staging environment that closely mirrors production, validating performance improvements and assessing potential impacts on resource utilization and security posture before deploying to production. Option B. Increase storage, wired tiger, engine config, cache size GB to the maximum available RAM on the server and disable net. Max incoming connections to allow unlimited connections, as these are commonly cited performance tuning tips. Option C. Implement changes to storage, wired tiger, engine config, cache size GB and net. Max incoming connections directly in the production environment during business hours, monitoring only query latency. Option D. Focus solely on tuning query analysis. Slow operation threshold MS to a very high value to reduce the reporting of slow queries, without altering other configuration parameters. The correct answer is C. Implement changes to storage, wired tiger, engine config, cache size GB and net, max incoming connections directly in the production environment during business hours, monitoring only query latency. Explanation: this scenario is professionally challenging because it requires balancing performance optimization with security and operational stability, all within the context of specific MongoDB configuration, best practices, and potential regulatory compliance. The DBA must understand how different configuration options impact the system and make informed decisions that align with business needs and risk tolerance. The correct approach represents best professional practice because it prioritizes a systematic, evidence-based method for evaluating configuration changes. By testing changes in a staging environment that mirrors production, the DBA can identify potential performance regressions or security vulnerabilities before they impact live operations. This proactive approach aligns with the principle of due diligence, ensuring that changes are well understood and their implications are mitigated. It also supports operational integrity and data availability, which are critical for business continuity and can be implicitly or explicitly required by various data governance frameworks. An incorrect approach that involves immediately applying changes to production without prior testing fails to uphold professional standards. This bypasses essential risk assessment and validation steps, potentially leading to system downtime, data corruption, or security breaches. Such actions could be considered negligent and may violate internal policies or industry best practices related to change management and operational risk. Another incorrect approach, focusing solely on performance metrics without considering security implications, is also professionally unsound. Security is paramount, and configuration changes that enhance performance at the expense of security create significant vulnerabilities. This oversight could lead to unauthorized access, data exfiltration, or compliance violations if sensitive data is exposed. Finally, an approach that relies on anecdotal evidence or common wisdom without empirical validation is unprofessional. While community knowledge is valuable, it should not replace rigorous testing and analysis tailored to the specific environment and workload. Relying on unverified information increases the risk of introducing unintended negative consequences. The professional reasoning process for similar situations involves 1. Understanding the business impact and requirements driving the proposed change. 2. Thoroughly researching the configuration options and their documented effects. 3. Developing a comprehensive test plan, including performance, security, and stability testing. 4. Executing tests in a representative staging environment. 5. Analyzing test results to confirm the desired outcomes and identify any adverse effects. 6. Implementing changes in production during a planned maintenance window with a rollback strategy. 7. Monitoring the system post-change to ensure continued stability and performance. Question 7. Consider a scenario where a new e-commerce application is being developed on MongoDB. The development team is under pressure to launch quickly and proposes a data model where all product details, customer reviews, and order history are embedded within a single customer document. As the MongoDB DBA, you are concerned about the potential long-term performance and scalability implications of this highly denormalized approach as the user base and product catalog grow significantly. Which of the following modeling strategies best addresses these concerns while still allowing for agile development? Option A. Embed all related data, including customer reviews and order history, within the customer document to minimize the number of documents a query needs to access. Option B. Embed frequently accessed, small, and stable data within parent documents, but use references for large, frequently updated, or infrequently accessed related data and design indexes to support common query patterns. Option C. Use a separate collection for each type of related data, e.g., reviews, orders, and perform client-side joins to reconstruct the complete customer view. Option D. Rely solely on MongoDB's dynamic schema to adapt the data structure as needed, without predefining relationships or indexes, to maximize development flexibility. The correct answer is B. Embed frequently accessed, small and stable data within parent documents, but use references for large, frequently updated, or infrequently accessed related data, and design indexes to support common query patterns. Explanation. This scenario presents a common challenge for MongoDB DBAs, balancing the immediate need for rapid application development with the long-term implications of data modeling choices on performance and scalability. The pressure to deliver features quickly can lead to denormalized or poorly structured data, which, while easy to implement initially, can become a significant bottleneck as data volume and query complexity increase. The professional challenge lies in anticipating future growth and query patterns, and making informed modeling decisions that support scalability without unduly hindering development velocity. This requires a deep understanding of MongoDB's query engine, indexing strategies, and the trade-offs inherent in different data modeling techniques. The correct approach emphasizes proactive data modeling for performance and scalability. This involves designing schemas that minimize read amplification, optimize for common query patterns, and leverage MongoDB's features like embedded documents and arrays judiciously. For instance, embedding related data, when it's frequently accessed together, can significantly reduce the number of read operations, thereby improving query performance. Similarly, choosing appropriate shard keys is crucial for distributing data and query load across a cluster, enabling horizontal scalability. This approach represents best professional practice because it aligns with the core responsibilities of a DBA, ensuring the database system is robust, performant, and scalable to meet evolving business needs. It demonstrates foresight and a commitment to long-term system health, preventing costly refactoring and performance degradation down the line. An incorrect approach that prioritizes only immediate development speed without considering scalability would be to excessively denormalize data, leading to large, complex documents that are difficult to query efficiently and constrain memory. This fails to consider the potential for data duplication and the challenges in maintaining data consistency across multiple copies, which can lead to performance degradation as the dataset grows. Another incorrect approach would be to neglect indexing, assuming MongoDB's dynamic schema will handle all query needs. This overlooks the critical role of indexes in speeding up query execution and can result in full collection scans for even simple queries, severely impacting performance and scalability. A third incorrect approach might involve choosing a shard key based on superficial criteria without analyzing query patterns or data distribution, leading to hot shards and uneven cluster utilization, which directly impedes scalability. These approaches are professionally unacceptable because they demonstrate a lack of understanding of database fundamentals and can lead to significant operational issues, increased costs, and a negative impact on user experience. A professional decision-making process for similar situations should involve a thorough impact assessment. This includes understanding the application's current and projected data volume, query patterns, read/write ratios, and latency requirements. Engaging with development teams to understand their immediate needs and future roadmap is essential. Then, evaluating different data modeling strategies, e.g., embedding VS, referencing document structure, array usage, against these requirements, considering the implications for indexing and sharding. The decision should be based on a clear understanding of the trade-offs, prioritizing solutions that offer the best balance of development agility and long-term performance and scalability, with a bias towards proactive design. Question 8. The investigation demonstrates that a financial services firm utilizing MongoDB for storing customer transaction data has been flagged for potential noncompliance with data protection regulations due to inadequate security configurations. The firm's current setup relies heavily on network firewalls for perimeter security, but lacks granular control over data access within the database itself, and has not implemented encryption for data both at rest and in transit. Which of the following configurations best addresses the regulatory requirements for protecting sensitive customer financial data? Option A. Focus on optimizing query performance and indexing strategies, as efficient data retrieval is considered the primary regulatory concern for financial data. Option B. Disable all authentication mechanisms within MongoDB, trusting that the application layer will handle all necessary security checks before interacting with the database. Option C. Rely solely on network segmentation and firewall rules to isolate the MongoDB cluster from other internal networks, assuming this provides sufficient protection for sensitive data. Option D. Implement role-based access control (RBAC) to define specific permissions for users and applications accessing customer data, enable encryption at rest for all sensitive data fields, and configure TLS/SSL for all client-server connections to encrypt data in transit. Correct answer is D. Implement role-based access control RBAC to define specific permissions for users and applications accessing customer data, enable encryption at rest for all sensitive data fields, and configure TLS/SSL for all client-server connections to encrypt data in transit. Explanation. The investigation demonstrates a critical need for robust data security and compliance within a MongoDB environment, particularly concerning sensitive customer information. The challenge lies in balancing the operational benefits of MongoDB's features with the stringent regulatory requirements for data protection. Professionals must understand how to leverage these features in a manner that aligns with compliance mandates, ensuring data integrity, confidentiality, and availability without compromising user privacy or exposing the organization to legal repercussions. The correct approach emphasizes the proactive implementation of MongoDB's built-in security features, such as role-based access control RBAC and encryption at rest, to meet regulatory obligations. This aligns with best practices for data governance and privacy regulations, which mandate that organizations implement appropriate technical and organizational measures to protect personal data. By configuring RBAC, administrators ensure that access to sensitive data is restricted to authorized personnel only, directly addressing the principle of least privilege. Encryption at rest protects data from unauthorized physical access to storage media. These features are fundamental to demonstrating due diligence and compliance with data protection laws. An incorrect approach that relies solely on network-level security without granular access controls fails to address the internal threat landscape or the principle of least privilege, which is a cornerstone of many data protection regulations. This oversight could lead to unauthorized access by internal users who may have broader network privileges but no legitimate need to access specific sensitive data, resulting in a regulatory violation. Another incorrect approach that neglects encryption for data in transit exposes sensitive information to interception during network transmission. This directly contravenes regulations that require protection of data both at rest and in transit, leaving the organization vulnerable to data breaches and associated penalties. Finally, an approach that ignores auditing and logging capabilities hinders the ability to detect and respond to security incidents or compliance breaches. Regulatory frameworks often require organizations to maintain audit trails to demonstrate accountability and to investigate any potential misuse of data. The absence of comprehensive logging makes it impossible to fulfill these requirements, leading to significant compliance failures. Professionals should adopt a risk-based approach, continuously assessing data sensitivity and regulatory requirements. This involves understanding the specific data being stored, the applicable regulations e.g., GDPR, CCPA, HIPAA, depending on the jurisdiction and data type, and then mapping MongoDB's features to meet those requirements. Regular security audits, penetration testing, and ongoing training for administrators are crucial components of a comprehensive compliance strategy. Question 9. Upon reviewing the data storage strategy for a new MongoDB deployment, a DBA is considering how to best represent data within the database. The application primarily interacts with MongoDB for internal data processing and querying, with occasional data exports in JSON format. Which approach best leverages MongoDB's capabilities while ensuring efficient data handling and integrity? Option A. Prioritize human readability of JSON for all internal database operations, even if it introduces performance overhead. Option B. Treat BSON and JSON as fully interchangeable for all MongoDB operations, without considering their underlying differences. Option C. Exclusively use JSON for all data storage and retrieval to maintain human readability across all operations. Option D. Utilize BSON for all internal data storage and retrieval, and convert to JSON only when exporting data for external consumption. The correct answer is D. Utilize BSON for all internal data storage and retrieval, and convert to JSON only when exporting data for external consumption. Explanation. This scenario is professionally challenging because the choice of data representation directly impacts data integrity, performance, and compliance with potential future data governance requirements. while BSON is MongoDB's native binary format, understanding its relationship with JSON and the implications of choosing one over the other for specific use cases is crucial for a DBA. The correct approach involves understanding that BSON is a superset of JSON, designed for efficient storage and traversal within MongoDB. It supports additional data types beyond JSON basic primitives, which can be leveraged for richer data representation and improved query performance. Choosing BSON for internal storage and retrieval within MongoDB is best professional practice as it aligns with the database's design principles, optimizes performance by reducing serialization/deserialization overhead, and ensures all MongoDB features are fully utilized. This approach adheres to the implicit regulatory expectation of maintaining data integrity and efficient system operation, which are foundational to many data governance frameworks. An incorrect approach would be to exclusively use JSON for all data storage and retrieval, even when BSON offers advantages. This could lead to performance degradation due to the overhead of converting JSON to BSON for internal processing and back to JSON for external consumption. While JSON is human-readable and widely interoperable, forcing its use where BSON is native can introduce inefficiencies. From a regulatory perspective, this might not directly violate a specific law, but could indirectly lead to non-compliance with performance-related service-level agreements or data processing efficiency mandates, which are often implied in data handling regulations. Another incorrect approach would be to misunderstand the relationship between BSON and JSON, believing they are interchangeable for all MongoDB operations. This could lead to data loss or corruption if attempting to store BSON-specific data types directly in a JSON-only context without proper handling. This failure to understand the underlying data representation can lead to data integrity issues, which are a direct concern for data protection regulations. Finally, an incorrect approach would be to prioritize human readability of JSON over the performance benefits of BSON for all internal database operations without a clear justification. While transparency is important, the primary responsibility of a DBA is to ensure the efficient and reliable operation of the database. Sacrificing performance for readability in a context where it's not a primary requirement can lead to system bottlenecks, potentially impacting compliance with uptime and performance standards. The professional reasoning framework for this situation involves 1. Understanding the core technologies. Recognize BSON as MongoDB's optimized binary format and its relationship to JSON. 2. Evaluating use cases. Determine where BSON advantages in performance and data type support are most beneficial. 3. Prioritizing efficiency and integrity. Ensure the chosen data representation supports optimal database performance and maintains data accuracy. 4. Considering interoperability needs. Balance internal efficiency with external data exchange requirements, using appropriate conversion mechanisms when necessary. Question 10. Stakeholder feedback indicates that users are experiencing significant delays when interacting with the MongoDB database, particularly during peak hours. As a MongoDB certified DBA associate, which of the following approaches would be the most effective and professionally sound method to address these performance concerns? Option A. Implement a series of broad, unverified database configuration changes across all collections, based on common performance tuning recommendations found online, to see if any improvements occur. Option B. Dismiss the feedback as user perception and continue with routine maintenance, as no critical alerts have been triggered in the monitoring system. Option C. Immediately initiate a hardware upgrade for the database servers, assuming that increased capacity will resolve the perceived performance issues without further investigation. Option D. Conduct a thorough analysis of key performance metrics, including query execution times, index hit rates, connection pooling statistics, and system resource utilization, CPU, memory, disk I/O, to identify specific bottlenecks and areas for optimization. The correct answer is D. Conduct a thorough analysis of key performance metrics, including query execution times, index hit rates, connection pooling statistics, and system resource utilization, CPU, memory, disk I/O, to identify specific bottlenecks and areas for optimization. Explanation. Scenario analysis. This scenario is professionally challenging because it requires balancing immediate stakeholder concerns with the long-term health and performance of a critical database system. The pressure to resolve perceived performance issues quickly can lead to hasty decisions that might not address the root cause or could introduce new problems. A DBA must navigate conflicting priorities, understand the nuances of performance metrics, and communicate effectively with stakeholders who may not have deep technical expertise. Correct approach analysis. The correct approach involves a systematic, data-driven investigation of performance metrics. This aligns with best professional practices for database administration, emphasizing proactive monitoring, root cause analysis, and informed decision-making. By examining specific metrics like query execution times, index usage, connection counts, and resource utilization, CPU, memory, disk I/O, the DBA can identify actual bottlenecks. This methodical approach ensures that any proposed solutions are targeted and effective, preventing unnecessary changes that could destabilize the system or incur additional costs. It also supports a culture of continuous improvement and operational excellence. Incorrect approaches analysis. One incorrect approach involves immediately implementing broad, unverified optimizations based on anecdotal feedback. This is professionally unacceptable because it bypasses the critical step of data-driven analysis. Without understanding the specific metrics indicating a problem, such optimizations are speculative and could negatively impact performance by introducing inefficient configurations, increasing resource contention, or even causing downtime. This approach demonstrates a failure to adhere to sound engineering principles and could lead to regulatory or compliance issues if performance degradation impacts service-level agreements (SLAs), or data integrity. Another incorrect approach is to dismiss stakeholder feedback entirely without any investigation. This is professionally unethical and unacceptable. While stakeholders may not always identify the precise technical issue, their feedback is a valuable indicator of user experience and potential system strain. Ignoring such feedback can lead to a deterioration of trust, missed opportunities to identify emerging problems, and potential breaches of service commitments. It also represents a failure in communication and collaboration, which are essential for effective IT service delivery. A third incorrect approach is to focus solely on hardware upgrades as a solution without analyzing the software and query performance. While hardware can be a factor, it is often not the primary bottleneck. Blindly upgrading hardware without understanding the underlying performance metrics is a costly and inefficient strategy. It fails to address potential issues with inefficient queries, missing indexes, or suboptimal database configurations, which are often the true culprits behind performance degradation. This approach demonstrates a lack of analytical rigor and can lead to wasted resources and continued performance problems. Professional reasoning. Professionals should adopt a structured problem-solving framework. This begins with clearly defining the problem based on stakeholder feedback. Next, it involves gathering relevant performance metrics using appropriate monitoring tools. The data should then be analyzed to identify root causes and potential bottlenecks. Based on this analysis, a set of targeted solutions can be proposed, prioritized, and implemented. Finally, the impact of these solutions must be monitored and validated. This iterative process ensures that decisions are informed, effective, and aligned with business objectives and operational best practices. Question 11. Examination of the data shows that the current single-node MongoDB deployment is experiencing significant performance degradation during peak hours, and the application team has requested a solution to improve read and write throughput and ensure high availability. The dataset is projected to grow by 30% annually. Which of the following strategies best addresses these requirements while adhering to best practices for scalability and resilience? Option A. Upgrade the existing single-node hardware to a more powerful machine and increase the RAM to accommodate the growing dataset and traffic. Option B. Migrate the data to a different NoSQL database technology that is known for its horizontal scalability, without further analysis of the current MongoDB deployment's specific needs. Option C. Implement sharding with a carefully selected shard key that distributes data evenly across multiple shards, and configure replica sets for each shard to ensure data redundancy and automatic failover. Option D. Implement a read-only replica set for the existing single node to handle read traffic, while all write operations continue to go to the primary node. Correct answer is C. Implement sharding with a carefully selected shard key that distributes data evenly across multiple shards and configure replica sets for each shard to ensure data redundancy and automatic failover. Explanation: this scenario presents a common challenge for MongoDB DBAs, ensuring data availability and performance under increasing load while adhering to best practices for sharding and replication. The professional challenge lies in balancing the immediate need for scalability and resilience with the long-term implications of architectural decisions, particularly concerning data distribution and consistency. A hasty or ill-informed decision can lead to performance degradation, increased operational complexity, and potential data loss or corruption, all of which have significant business and regulatory ramifications. The correct approach involves a thorough understanding of the application's read/write patterns, data volume growth, and the specific requirements for high availability and disaster recovery. Implementing sharding with a well-chosen shard key is paramount for distributing data across multiple servers, thereby improving query performance and enabling horizontal scaling. Coupled with replica sets, sharding ensures data redundancy and automatic failover, minimizing downtime. This strategy aligns with industry best practices for database management, emphasizing resilience, scalability, and maintainability. From a regulatory perspective, maintaining data integrity and availability is often a compliance requirement, especially for sensitive data, making robust replication and sharding essential. An incorrect approach would be to implement sharding without careful consideration of the shard key. A poorly chosen shard key can lead to hot shards, where a disproportionate amount of data and traffic is concentrated on a single shard, negating the benefits of sharding and potentially causing performance bottlenecks. This could lead to service disruptions and impact the ability to meet service-level agreements, SLAs, which can have contractual and potentially regulatory implications if data availability is a mandated requirement. Another incorrect approach is to implement replication without a clear strategy for read preference or failover. This could result in inconsistent data reads or prolonged downtime during primary node failures, again impacting SLAs and potentially violating data integrity requirements. Furthermore, neglecting to monitor shard balancing and replica set health post-implementation can lead to gradual performance degradation and increased risk of data loss, which are critical failures in professional database management. The professional decision-making process should involve a phased approach. First, a comprehensive assessment of current and projected data needs, application access patterns, and availability requirements. Second, designing the sharding strategy, including the selection of an appropriate shard key and configuring replica sets with appropriate read preferences and failover mechanisms. Third, implementing the changes in a controlled environment, followed by rigorous testing to validate performance, availability, and data consistency. Finally, continuous monitoring and performance tuning are essential to adapt to evolving workloads and ensure the long-term health and efficiency of the database cluster. Question 12. The control framework reveals that a new application requiring high availability and read scalability is being developed. The database administrator must select an appropriate MongoDB architecture, considering the principles of data integrity and operational resilience. Which architectural approach best satisfies these requirements without introducing undue complexity for the initial deployment? Option A, a sharded cluster with multiple shards and config servers. Option B, a replica set with a primary and two secondary members. Option C, a replica set with one primary and one secondary member. Option D, a single standalone MongoDB instance. The correct answer is B, a replica set with a primary and two secondary members. Explanation: scenario analysis. This scenario presents a common challenge for MongoDB DBAs, selecting the most appropriate architecture for a new application deployment. The challenge lies in balancing performance, availability, and operational complexity while adhering to the principles of robust data management and security, which are implicitly governed by the general principles of data integrity and operational resilience expected in professional IT environments. The DBA must understand the trade-offs inherent in different MongoDB architectures to make an informed decision that aligns with business requirements and minimizes risk. Correct approach analysis. Choosing a replica set with at least 3 members, including a primary and 2 secondaries, represents best professional practice. This configuration provides high availability through automatic failover to a secondary, if the primary becomes unavailable. It also enables read scaling by directing read operations to secondaries. This approach aligns with the fundamental principle of ensuring data accessibility and durability, crucial for business continuity and operational integrity. The redundancy inherent in a replica set directly addresses the risk of single points of failure, a core tenet of sound IT architecture. In correct approaches analysis, deploying a single standalone MongoDB instance is professionally unacceptable because it creates a single point of failure. If this instance fails, the application becomes unavailable, leading to significant business disruption and data loss risk. This violates the principle of operational resilience and data availability. Implementing a replica set with only 2 members, one primary, one secondary, is also professionally problematic. While it offers some redundancy, it does not provide automatic failover in all scenarios, particularly in network partition events, where the 2 members might not be able to communicate. This can lead to split-brain scenarios and data inconsistencies, undermining data integrity and availability. Opting for a sharded cluster without sufficient understanding of its complexity for this specific application is professionally risky. While sharding offers scalability for very large datasets, it introduces significant operational overhead and complexity. If the application's data volume and throughput do not necessitate sharding, its implementation can lead to unnecessary operational burden and potential performance issues if not configured optimally, without providing a proportional benefit. Professional reasoning. Professionals should approach architectural decisions by first thoroughly understanding the application's requirements, including expected data volume, read/write patterns, availability needs, and disaster recovery objectives. They should then evaluate potential MongoDB architectures against these requirements, considering the trade-offs in terms of performance, scalability, availability, and operational complexity. A phased approach, starting with a simpler, highly available configuration like a 3-member replica set and scaling to sharding only when truly necessary, is often the most prudent strategy. This decision-making process emphasizes risk mitigation, cost-effectiveness, and alignment with business goals. Question 13. The monitoring system demonstrates a critical security vulnerability by exposing sensitive performance metrics and system configuration through an unauthenticated endpoint, potentially allowing unauthorized access to internal cluster details. Which of the following actions best addresses this risk while adhering to best practices for data security and compliance? Option A. Replace the current monitoring tool with MongoDB Compass, focusing solely on interactive performance analysis for individual nodes. Option B. Continue using the unauthenticated endpoint for ease of access, but implement a firewall rule to restrict access to only known internal IP addresses. Option C. Document the vulnerability and plan to address it in the next major system upgrade cycle, assuming the risk is low for now. Option D. Immediately disable the unauthenticated endpoint and reconfigure the monitoring tool to use encrypted connections with strong authentication, ensuring that only authorized personnel can access performance data. Correct answer is D. Immediately disable the unauthenticated endpoint and reconfigure the monitoring tool to use encrypted connections with strong authentication, ensuring that only authorized personnel can access performance data. Explanation. This scenario presents a professional challenge because a DBA must balance the immediate need for performance tuning with the potential for introducing new vulnerabilities or violating data privacy regulations. Chosen monitoring tool and its configuration directly impact the ability to detect and respond to security threats and compliance issues. Careful judgment is required to ensure that monitoring activities do not inadvertently compromise sensitive data or create new attack vectors. The correct approach represents best professional practice because it leverages a comprehensive, integrated monitoring solution like MongoDB Cloud Manager or Ops Manager. These tools are designed with security and compliance in mind, offering features such as role-based access control, audit logging, and data masking capabilities. By centralizing monitoring and management, a DBA can ensure consistent application of security policies across the environment, facilitate rapid incident response, and maintain an auditable trail for regulatory compliance. This proactive and integrated approach minimizes the risk of security breaches and ensures adherence to data protection laws by providing granular control and visibility. An incorrect approach that relies solely on MongoDB Compass for real-time performance metrics without proper security configurations poses significant regulatory and ethical failures. MongoDB Compass, while excellent for interactive exploration and basic performance monitoring, is primarily a client-side tool. If not used within a secure network perimeter or with appropriate authentication, it could expose sensitive cluster information to unauthorized access. Furthermore, relying on it for security-related monitoring might miss critical threat indicators that more specialized tools would detect. This approach fails to meet the ethical obligation to protect data and the regulatory requirement to implement robust security measures. Another incorrect approach, using a third-party, unvetted open-source monitoring tool, carries substantial regulatory and ethical risks. Such tools may not have undergone rigorous security audits, potentially introducing vulnerabilities into the production environment. They might also lack features necessary for compliance, such as comprehensive audit trails or data anonymization capabilities. Ethically, deploying an unverified tool without understanding its data handling practices could lead to unintentional data leakage or non-compliance with data privacy regulations. The professional reasoning process for similar situations should involve a thorough risk assessment of any monitoring tool or configuration. This includes evaluating its security features, compliance certifications, data handling policies, and integration capabilities with existing security infrastructure. Professionals should prioritize solutions that offer centralized management, granular access control, and robust auditing. They must also consider the principle of least privilege, ensuring that monitoring tools and their users only have access to the data and functionalities necessary for their tasks, thereby minimizing the attack surface and potential for misuse. Question 14. Analysis of a stakeholder's request for robust data integrity controls on a critical customer data collection within a MongoDB database, where the stakeholder emphasizes the need to prevent incomplete or malformed records, mirroring expectations from traditional relational database environments. Which of the following approaches best addresses this requirement, while adhering to professional best practices for data governance and integrity in a regulated industry? Option A. Advise the stakeholder that MongoDB's schema flexibility inherently negates the need for explicit data validation rules. Option B. Develop custom server-side JavaScript functions to validate data on a per-document basis during write operations. Option C. Rely exclusively on application-level code to perform all data validation before inserting or updating documents in the database. Option D. Implement collection-level schema validation rules in MongoDB to define required fields, data types, and value constraints for incoming documents. The correct answer is D. Implement collection-level schema validation rules in MongoDB to define required fields, data types, and value constraints for incoming documents. Explanation. Scenario analysis. This scenario presents a common challenge for MongoDB DBAs, balancing data integrity requirements with the flexibility of a NoSQL database. Stakeholders, particularly those from regulated industries, often expect data validation and constraint enforcement mechanisms similar to those found in relational databases. The challenge lies in implementing these controls effectively within MongoDB's schema-flexible nature, ensuring compliance with internal policies and potentially external regulations without hindering application development or performance. The need for robust data validation is paramount to prevent data corruption, ensure data accuracy for reporting and analytics, and maintain trust in the data. Correct approach analysis. The correct approach leverages MongoDB's built-in schema validation features. By defining a schema validation rule at the collection level, the DBA can enforce data types, required fields, and value ranges for documents being inserted or updated. This is best professional practice because it directly addresses the stakeholder's need for data integrity and constraint enforcement at the database level, providing a consistent and reliable mechanism. This aligns with general data governance principles and, in regulated environments, helps meet requirements for data accuracy and completeness. It is a proactive measure that prevents invalid data from entering the system, reducing the burden on application-level validation and potential data cleanup efforts. Incorrect approaches analysis. Relying solely on application-level validation is an incorrect approach because it creates a single point of failure. If the application logic is flawed, or if data is inserted or modified through other means, e.g., direct shell access other applications. Invalid data can bypass these checks. This poses a significant regulatory and ethical risk, as it can lead to inaccurate reporting, non-compliance with data quality standards, and potential legal repercussions if the data is used for critical decision-making or regulatory submissions. It also increases the operational burden of maintaining validation logic across multiple applications. Implementing custom validation logic in application code without leveraging database-level features is also professionally unsound. While it might seem flexible, it suffers from the same single point of failure as relying solely on application-level validation. Furthermore, it duplicates effort and can lead to inconsistencies if not meticulously managed. From a regulatory perspective, it can be harder to audit and prove consistent enforcement compared to a database-level schema. Ignoring stakeholder requests for data validation and relying on the inherent flexibility of MongoDB without any controls is the most egregious failure. This approach disregards the fundamental need for data integrity and can lead to severe data quality issues. In a regulated environment, this would be a direct violation of data governance policies and potentially specific industry regulations requiring data accuracy and reliability. It erodes stakeholder trust and can have severe financial and reputational consequences. Professional reasoning. When faced with stakeholder requests for data validation in MongoDB, a professional DBA should first understand the specific requirements and the underlying business or regulatory drivers. The primary decision-making framework involves evaluating MongoDB's native capabilities for enforcing these requirements. Schema validation is the most robust and recommended method for enforcing data integrity at the database level. If native features are insufficient, the DBA should explore other database-level mechanisms or carefully consider the trade-offs of application-level enforcement, always prioritizing a layered approach to data protection and integrity. The goal is to implement controls that are effective, auditable, and maintainable, ensuring compliance and stakeholder confidence. Question 15. Strategic planning requires a MongoDB DBA to design a data model that not only optimizes query performance, but also adheres to strict data privacy regulations. Considering the potential for sensitive personal information to be stored, which data modeling approach best balances these competing requirements while ensuring regulatory compliance? Option A. Embed all related data within a single document to minimize the number of database operations, regardless of the sensitivity of the embedded information. Option B. Design the schema to facilitate granular access controls and comprehensive auditing capabilities, potentially using references for highly sensitive data that require stricter isolation and access management. Option C. Rely solely on application-level logic to enforce all data access restrictions and audit trails, assuming the database itself does not need specific compliance-oriented modeling features. Option D. Prioritize read performance by denormalizing extensively, duplicating sensitive data across multiple documents to ensure quick retrieval, without specific consideration for access control on each duplicated instance. The correct answer is A. Embed all related data within a single document to minimize the number of database operations, regardless of the sensitivity of the embedded information. Explanation. Scenario analysis. This scenario is professionally challenging because it requires balancing the technical efficiency of data modeling with the stringent requirements of regulatory compliance, specifically concerning data privacy and integrity. A DBA must not only understand MongoDB's capabilities, but also how its implementation can impact adherence to data protection laws. The pressure to deliver performance solutions can sometimes conflict with the need for robust auditing and access control, making careful judgment essential. Correct approach analysis. The correct approach prioritizes the establishment of a data model that inherently supports regulatory compliance. This involves designing schemas that facilitate granular access control, enable comprehensive auditing of data modifications, and support data retention policies. For instance, embedding sensitive data only when strictly necessary, and when access controls can be effectively managed, or using references for sensitive information that requires separate, more stringent access controls, aligns with principles of data minimization and purpose limitation. Implementing robust indexing strategies that also support efficient querying for audit trails or data subject access requests is crucial. This approach represents best professional practice because it embeds compliance into the foundational design, reducing the risk of costly retrofits and potential regulatory breaches. It demonstrates a proactive understanding of legal obligations, ensuring that the database infrastructure is not only functional, but also legally sound. Incorrect approach is analysis. An approach that focuses solely on performance optimization without considering regulatory implications is professionally unacceptable. For example, denormalizing extensively to improve read performance without assessing the increased risk of data inconsistency or the difficulty in managing access to duplicated sensitive data can lead to regulatory failures. If sensitive data is embedded in numerous documents without appropriate access controls, it violates principles of data protection by increasing the exposure of that data. Another incorrect approach is to defer all compliance considerations to application-level logic. While application logic plays a role, relying on it entirely for data access control and auditing creates a significant security and compliance gap. If the application layer fails or is bypassed, the underlying data is unprotected, leading to potential breaches of data privacy regulations. This approach fails to leverage the database's inherent security features and can result in a lack of centralized, auditable control over sensitive information. Furthermore, an approach that ignores data retention and deletion requirements during the initial modeling phase is also problematic. Designing a model that makes it difficult or impossible to enforce data retention policies or to securely delete data upon request, e.g., for GDPR right to be forgotten, can result in non-compliance with data protection laws. This failure to plan for the data lifecycle can lead to the unlawful retention of personal data. Professional reasoning. Professionals should adopt a risk-based approach to data modeling, integrating compliance requirements from the outset. This involves understanding the specific regulatory landscape applicable to the data being stored and processed. Key decision-making steps include identifying sensitive data elements, determining the necessary level of access control and auditing for each, assessing the implications of different modeling techniques, embedding VS, referencing on security and compliance, and planning for data lifecycle management, retention, deletion, access requests. Collaboration with legal and compliance teams is paramount to ensure that technical decisions align with legal obligations. Question 16. The efficiency study reveals that the current role-based access control (RBAC) implementation in a critical MongoDB deployment is leading to significant operational overhead and potential security risks due to overly broad permissions. To address this, which of the following strategies best aligns with the principle of least privilege and enhances administrative efficiency while maintaining robust security? Option A. Create custom roles that precisely define the necessary privileges for specific user groups, granting only the minimum permissions required for their tasks, and assign these custom roles to users. Option B. Assign the cluster admin role to all database administrators to ensure they have the necessary authority to manage the entire cluster and resolve issues quickly. Option C. Consolidate all user permissions into a single, highly privileged role that encompasses all potential access needs across the entire MongoDB deployment. Option D. Grant the read, write any database role to all application service accounts to simplify database access for all applications. The correct answer is A. Create custom roles that precisely define the necessary privileges for specific user groups, granting only the minimum permissions required for their tasks, and assign these custom roles to users. Explanation. The efficiency study reveals that the current role-based access control (RBAC) implementation in a critical MongoDB deployment is leading to significant operational overhead and potential security risks. The challenge lies in balancing granular control over sensitive data with the need for efficient administration and adherence to data governance principles. Overly permissive roles can lead to unauthorized data access or modification, while overly restrictive roles can hinder legitimate business operations and increase the burden on the DBA team for frequent permission adjustments. The correct approach involves a systematic review and refinement of existing roles, aligning them with the principle of least privilege. This means granting users only the minimum permissions necessary to perform their job functions. For MongoDB Certified DBA Associate, this translates to understanding the specific built-in roles, e.g., read, read-write, DB admin, cluster admin, and custom roles available in MongoDB. by creating custom roles that precisely define the allowed database operations, e.g., specific collection access, read-only on certain fields, and applying them to users or groups. The DBA ensures that access is strictly controlled. This aligns with general data security, best practices, and regulatory expectations for data protection, which often mandate controls to prevent unauthorized access and maintain data integrity. An incorrect approach would be to grant broad administrative roles, like cluster admin or user admin any database, to individuals who only require limited access to specific databases or collections. This violates the principle of least privilege and creates an unnecessary security vulnerability. Such an approach could lead to accidental or malicious data breaches, which would be a direct failure to implement adequate security controls as expected under data protection regulations. Another incorrect approach is to assign the same overly broad role to multiple users with vastly different responsibilities. This lacks the necessary granularity to track and audit access effectively. If an incident occurs, it becomes difficult to pinpoint who performed a specific action, hindering forensic investigations and accountability. This failure to implement granular access controls can be seen as a lapse in due diligence regarding data security and compliance. Finally, relying solely on default MongoDB roles without customization for specific organizational needs is also an inadequate approach. While default roles provide a baseline, they are often too general for secure and efficient operation in a production environment. This can lead to either overpermissioning or underpermissioning, both of which present risks. The professional reasoning process for MongoDB certified DBA associate in this scenario should involve 1. Understanding the business requirements and the specific data access needs of different user groups. 2. Mapping these requirements to MongoDB's RBAC model, identifying opportunities to leverage built-in roles and the necessity for custom roles. 3. Implementing the principle of least privilege by creating and assigning granular roles. 4. Regularly auditing role assignments and permissions to ensure they remain appropriate and to detect any unauthorized access attempts or misconfigurations. 5. Documenting the role structure and permission assignments for transparency and compliance. Question 17. Research into the most effective strategy for managing user and role permissions in a MongoDB deployment to ensure compliance with data access regulations and maintain operational efficiency. A DBA is considering several approaches. Which approach best aligns with the principle of least privilege and facilitates robust auditing? Option A. Create distinct roles for each specific job function within the organization, assigning only the necessary read, write, or delete privileges to each role, and then assign users to these roles. Option B. Create a single developer role with full administrative access to all databases and collections, and assign all development personnel to this role. Option C. Grant all users read-only access to all collections in the database to ensure no data is accidentally modified, and address specific write needs on a case-by-case basis through ad hoc permission grants. Option D. Assign broad administrative privileges to a central IT support team and a limited number of senior developers, allowing them to manage access for other users as needed. The correct answer is A. Create distinct roles for each specific job function within the organization, assigning only the necessary read, write, or delete privileges to each role, and then assign users to these roles. Explanation. This scenario presents a common challenge in database administration, balancing security requirements with operational efficiency when managing user access. The core difficulty lies in ensuring that only authorized personnel have the necessary privileges to perform their duties, while simultaneously avoiding overly restrictive permissions that hinder productivity or lead to security vulnerabilities through excessive delegation. Adhering to the principle of least privilege is paramount, especially in regulated environments, to minimize the attack surface and maintain data integrity. The correct approach involves a systematic process of defining roles based on job function, and then assigning granular permissions to those roles. This aligns with best practices for access control, ensuring that users are granted only the minimum permissions required to perform their specific tasks. This methodology directly supports regulatory compliance by providing a clear audit trail of who has access to what and why, and it minimizes the risk of unauthorized data access or modification. It promotes a secure and manageable database environment. An incorrect approach would be to grant broad administrative privileges to a wider group of users than necessary. This violates the principle of least privilege and significantly increases the risk of accidental or malicious data breaches. From a regulatory standpoint, this lack of granular control makes auditing difficult and can lead to non-compliance with data protection regulations, as it becomes challenging to demonstrate that data access is strictly controlled and limited to authorized personnel. Another incorrect approach is to assign permissions directly to individual users rather than through roles. This creates a management nightmare, making it extremely difficult to track and update permissions as personnel change or job responsibilities evolve. It also increases the likelihood of errors and inconsistencies in access control, potentially leading to security gaps. This ad hoc method is not auditable and fails to meet the requirements of robust security frameworks. Finally, a flawed approach would be to grant all users read-only access to all data, regardless of their role. While seemingly secure, this can still be problematic. It might prevent legitimate users from performing necessary tasks that require write or delete access, impacting operational efficiency. More importantly, it doesn't address the need for specific, restricted access for sensitive data, which is a critical aspect of data governance and regulatory compliance. The professional decision-making process for similar situations should begin with a thorough understanding of the organization's security policies and relevant regulatory requirements. This should be followed by an analysis of job functions and the data access needs associated with each. Implementing a role-based access control (RBAC) model, adhering to the principle of least privilege, and establishing a regular review process for user permissions are key components of effective user and role management. Question 18. The monitoring system demonstrates a high volume of connection attempts from unexpected IP addresses to a MongoDB replica set, coinciding with a recent configuration change that broadened network accessibility. Option A. Ignore the monitoring alerts, as increased connection attempts are a normal indicator of database activity and do not necessarily represent a security threat. Option B. Review the net. Bind IP setting in the MongoDB configuration file to restrict connections to authorized network interfaces and ensure authentication mechanisms are properly configured and enforced. Option C. Disable MongoDB's authentication entirely to simplify connection management and reduce potential connection errors. Option D. Immediately disable all network traffic filtering on the server hosting the MongoDB instance to allow all connections, assuming the unexpected IPs are legitimate. The correct answer is B. Review the net. Bind IP setting in the MongoDB configuration file to restrict connections to authorized network interfaces and ensure authentication mechanisms are properly configured and enforced. Explanation. This scenario presents a common challenge for MongoDB DBAs, balancing performance optimization with the need for robust security and compliance. The monitoring system's alert indicates a potential misconfiguration that could expose sensitive data or lead to unauthorized access, directly impacting data integrity and confidentiality. Careful judgment is required to identify the root cause and implement a solution that adheres to best practices and any applicable regulatory frameworks governing data handling and system security. The correct approach involves a thorough review of the MongoDB configuration files, specifically focusing on network binding settings and access control mechanisms. Best professional practice dictates that MongoDB instances should be configured to bind to specific authorized network interfaces, e.g., localhost or a private network, and that robust authentication and authorization, e.g., using X509 certificates or SCRAM, are enforced. This minimizes the attack surface and ensures that only authenticated and authorized clients can connect to the database. This aligns with general principles of data security, and depending on the specific jurisdiction and industry, could be mandated by regulations concerning data protection and system integrity. Binding MongoDB to all network interfaces 0.0.0.0 without appropriate firewall rules or access controls is a significant security failure. It exposes the database to the entire network, including potentially untrusted external networks, making it vulnerable to unauthorized access, data breaches, and denial of service attacks. This approach directly violates the principle of least privilege and could lead to regulatory penalties if data protection laws are breached. Disabling authentication entirely is a critical security lapse. It removes the primary barrier to unauthorized access, allowing any entity on the network to connect to the database and potentially access, modify, or delete sensitive data. This is a direct contravention of data security best practices and would likely be a violation of data privacy regulations. Ignoring the alert and continuing with the current configuration is professionally negligent. It demonstrates a disregard for system security and potential data integrity issues. This inaction can lead to severe security incidents, data breaches, and significant reputational damage, as well as potential legal and financial repercussions. The professional decision-making process should involve 1. Prioritizing security alerts based on their potential impact. 2. Investigating the root cause of the alert by examining system logs and configuration. 3. Consulting relevant security policies and regulatory requirements. 4. Implementing solutions that adhere to the principle of least privilege and defense in depth. 5. Thoroughly testing any changes before deploying them to production. 6. Documenting all changes and their justifications. Question 19. The assessment process reveals that an e-commerce application needs to store order information. Each order can contain multiple items, and it's crucial for the application to efficiently retrieve an entire order, including all its associated items, for display to the customer. The application also needs to ensure that an order and its items are always treated as a single unit, preventing situations where an order exists without its items or vice versa. Given these requirements, which document modeling approach is most appropriate for storing orders and their items in MongoDB? Option A. Embed the order items array directly within each order's document. Option B. Store order items in a separate collection and reference them using order ID in the order's document. Option C. Use a hybrid approach where some order items are embedded and others are linked in a separate collection. Option D. Create entirely separate documents for each order item, without any direct link back to the order's document. The correct answer is A. Embed the order items array directly within each order's document. Explanation. Scenario analysis. This scenario presents a common challenge in database design, balancing data retrieval efficiency with data integrity and update complexity. The core tension lies between the performance benefits of embedding related data and the maintainability advantages of linking. A DBA must consider the read/write patterns, data volume, and the relationships between entities to make an informed decision that aligns with application requirements and operational best practices. The challenge is amplified by the need to avoid potential data duplication and ensure consistency across related documents, which can impact application logic and user experience. Correct approach analysis. Embedding the order items array directly within the order's document is the best professional practice in this scenario. This approach optimizes read performance for retrieving an entire order with its associated items, as all necessary data resides in a single document. This reduces the number of database operations required, leading to faster query execution, which is crucial for user-facing applications. From a data integrity perspective, embedding ensures that an order and its items are always retrieved and updated together, preventing inconsistencies that could arise from separate collections. This aligns with the principle of data locality and minimizes the risk of orphaned order items. Incorrect approach is analysis. Linking order items in a separate collection and referencing them via order ID would lead to suboptimal read performance. Retrieving an order would necessitate a separate query to fetch its items, increasing latency and resource consumption. This violates the principle of efficient data access. Furthermore, managing consistency between the orders and order items collections becomes more complex, increasing the risk of data anomalies if updates are not handled carefully, potentially leading to regulatory compliance issues if accurate and consistent data is a requirement. Using a hybrid approach where some order items are embedded and others are linked introduces unnecessary complexity. This makes the data model inconsistent and harder to reason about, increasing the likelihood of application errors and maintenance overhead. It fails to leverage the benefits of either embedding or linking fully and creates a less predictable system, which can be problematic for auditing and data governance. Creating entirely separate documents for each order item without any direct link back to the order document would result in data fragmentation and an inability to reconstruct a complete order. This is a fundamental failure in data modeling, and would render the system unusable for its intended purpose, leading to severe operational and potential regulatory failures related to data completeness and accuracy. Professional reasoning. Professionals should approach this decision by first understanding the primary use cases of the data. If retrieving an entire order with its items is a frequent and performance-critical operation, embedding is generally preferred. If order items are frequently updated independently, or if the number of order items per order can grow to extremely large sizes, linking might be considered, but with careful performance tuning. The decision should be driven by a thorough analysis of read/write patterns, data relationships, and the application's performance requirements. Professionals should also consider the trade-offs in terms of data consistency and complexity of updates. Question 20. Which approach would be most appropriate for a MongoDB certified DBA associate to update a large collection of user profiles, where each profile requires conditional modifications based on specific user attributes, ensuring data integrity and minimizing the risk of partial updates? Option A. Forming a series of separate update operations without any transaction or batching mechanism to modify different fields across multiple documents. Option B. Executing individual atomic update operations on each document using MongoDB's update operators, targeting specific fields based on conditional logic. Option C. Deleting all user profiles and then reinserting them with the updated information. Option D. Fetching each user profile, modifying it in the application, and then reinserting the entire document. The correct answer is D. Fetching each user profile, modifying it in the application, and then reinserting the entire document. Explanation. This scenario presents a common challenge for MongoDB DBAs, efficiently and accurately managing data lifecycle operations while adhering to best practices for data integrity and performance. The core difficulty lies in choosing the most appropriate method for updating a large dataset where individual document modifications might be complex or conditional, balancing the need for atomicity with the potential for performance impact. The correct approach represents best professional practice because it leverages MongoDB's atomic update operators. These operators ensure that a single document is modified in an all-or-nothing manner, preventing partial updates and maintaining data consistency. This is crucial for regulatory compliance, as data integrity is paramount. By performing updates on a per-document basis using atomic operators, the DBA minimizes the risk of data corruption, which could lead to audit failures or breaches of data protection regulations. This method also generally offers better performance for targeted updates compared to fetching and reinserting entire documents, especially in large collections. An incorrect approach that involves fetching entire documents, modifying them in the application layer, and then reinserting them is professionally unacceptable. This method inherently lacks atomicity at the database level. If an error occurs during the reinsertion of a document, the original document might be lost, or a partial update could be introduced, leading to data inconsistency. This directly violates principles of data integrity and could have severe regulatory consequences, such as failing data audits or violating data accuracy requirements mandated by data protection laws. Furthermore, this approach can be significantly less performant due to the overhead of data transfer and the lack of atomic guarantees, increasing the risk of race conditions and data corruption. Another incorrect approach, performing multiple independent update operations without any form of transaction or batching mechanism, also poses significant risks. While individual update operators might be atomic, a sequence of such operations is not. If one update in the sequence succeeds and another fails, the data will be left in an inconsistent state. This lack of transactional integrity is a major regulatory concern, as it compromises the reliability and auditability of the data. It also makes troubleshooting and recovery much more complex, increasing operational risk. The professional decision-making process for such situations involves first understanding the specific data integrity requirements and any relevant regulatory mandates regarding data accuracy and consistency, then evaluating the technical capabilities of the database system to support atomic and transactional operations. For MongoDB, this means prioritizing the use of its built-in atomic update operators and, where necessary, leveraging multi-document transactions for operations spanning multiple documents. The DBA must consider the trade-offs between complexity, performance, and the absolute necessity of data integrity. In this case, the focus on atomic, per document updates aligns with the highest standards of data management and regulatory compliance.